Okay, let's start. First of all, I would like to say that I'm very glad to see you here. My name is Andrei Suflev, and I'm going to tell you about smart contract generation for dissemination to Wikipedia. This work was done with my colleague from ISPRAS and Higher School of Economics, Irina Nikish. So let's actually start. When reading some text and when percepting it, we are able to detect entities which are mentioned in this text. And we can acquire some knowledge from this text, and we can verify facts about these entities, or we can verify what we are reading. But actually, it's a two-way road, and the perception starts in the opposite direction. We are able to detect entities because we already know something about them. If they are completely new, we sometimes cannot say anything. Here is a small example. This is some sentence about the coat of arms of Nizhny Novgorod and the animals which are depicted here. I don't think that many people can right now clearly remember how the coat of arms of Nizhny Novgorod looks like, and can remember the minor differences in appearance of these animals. So, yeah, you can perceive this text somehow, but not very clearly, as well as the man who remembers all these entities. And actually, the problem may be even worse. For example, here. This is a sentence about Bougères and Toner and Young Department. And if you are not very familiar with French cuisine and with the geography of France, maybe you can't understand clearly what this sentence is about. Typically, for better understanding, for better perception, what would you do? Well, you'll fire up your favorite browser and go to Google, Yandex, Wikipedia, whatever, and search for them here. But there is a small problem because it causes context switch. So you were reading the text, now you have to go to the browser and to search. Then you're back to the text. Well, what was I reading about? I don't know. Then you find the second entity, which you don't know. You have to switch tab again, and so on and so on. And thus, instead of reading, you are switching. Actually, I don't want you to switch our context right now, so I'm showing you the picture of the entities which were on the previous slides. Okay, and I think that it will be very useful if always when you read something, you have some guy who's reading the text together with you and who is able to help you and to understand it, who is able to provide you some hints and some additional knowledge instead of constant context switching. And actually, Wikification is the solution for this task. Yeah, you can see it's here wiki part. It means that we are addressing Wikipedia and trying to use it as a knowledge base. So Wikification is actually about finding mentions in the text and determining their meanings. Let's look at this example. And let's start with the first minor task, with searching for mentions. The question arises whether we should select the largest entity or we should split it into smaller pieces. For example, is coat of arms of Nizhny Novgorod a single mention, or should we separate it into coat of arms of Nizhny Novgorod? And actually, in the second case, there is another question whether we should split coat of arms into coat and arms or not. And actually, this question is really hard, and different experts may have different opinions about the correct separation. And instead of doing that, we try to simplify the task a bit, and we say that our mentions are nailed down, and the task is only to define the correct meaning of each mention. But actually, it's still a challenge. The first problem is ambiguity. For example, you see here that there was a word deer, and actually this mention may have plenty of different meanings. Actually, deer is an animal, I think, you know, but there are different subkinds of this animal, like mouse deer and musk deer. Deer may be a surname of some person, it may be the name of the river, for example, like here. It may be a name of some humanly created object, like Great Wall Deer, it's Chinese pickup, and many, many others. And actually, there is another problem with non-obvious mappings. When you see big blue, of course, you may think of a whale, but sometimes it's IBM Corporation, because it's a nickname of this corporation. As I said, we use Wikipedia, and we download the whole encyclopedia and build a knowledge base from it. Entities of the knowledge base are called concepts. Then for each mention, we can build a mapping from this mention to a set of possible concepts, the possible meanings of this mention. And these mappings are built from the Wikipedia text, actually from anchor text of the link. Links. Moreover, each mention may have a special new value, or denoting that there is no correct value, no correct meaning, no concept in Wikipedia yet for the actual mention in some text. In such case, we say that there's just some, not in Wikipedia, or new value. Okay, we are done with the task, and now let's try to think how can we solve it. And the simplest approach is most common sense. In such case, we always return the same concept for the mention, and how can we select it? We just compute statistics all over the Wikipedia and select the most frequently used concept for each mention. But it totally ignores the text of the document, but it's quite useful. But there are, of course, several approaches, and one of the most popular and an approach which produces quite good results is the GLOW system, which is presented in the global and global algorithms for navigation to Wikipedia. It's at the bottom of the slide. So the idea is to look at the mention and to analyze different kinds of context of this mention, and do the same for possible meanings, and then to compare different contexts. Thus, we would be able to select the correct meaning. Okay, for each mention, we can take the whole document where this mention appeared and convert it into TF-IDF vector. That's quite easy. Then we can its text for M. Context for M is a bit different thing. We can look at the mention and select some words around it. Then we can easily create TF-IDF vector. Actually, we can do just the same things for concepts. As each concept has a corresponding Wikipedia page, we can take its text and create a TF-IDF vector. At the same time, we can scan through the whole Wikipedia, watch for links to this concept, select context around this link, and create TF-IDF vector. After that, we can compute a number of features. So, in fact, we create all pairs of these kinds of contexts for mention and the concept under consideration, and we compare it with Gaussian similarity. This is at the top of the slide. Then we can compute weighted versions. We can compute commonness. In fact, it's the probability of concept E being correct meaning of mention M. And we can compute popularity of concept E. In fact, it's the fraction of Wikipedia pages which link to E. All these features are passed to rank as well. Thus, we are able to score each meaning of the mention. If we select the best one, that's some kind of solution. But actually, there is a minor problem because ranker isn't possible to produce null value. What does it mean? It always ranks the possible meanings, but if it has it has a possible. It doesn't have such a meaning. It can do nothing. Thus, we use a linker which is a binary classifier. After that, we can create use local context as we can collect all the concepts and create and use it as global context. Here are different. This slide illustrates how we can compute features with global context. And okay, now I'm going to tell you about our contribution. It is inspired by the tutorial from the previous INL, which was given by Jörg Titelmann. And actually, we thought of Wikification being a neural machine translation test. When we have to translate documents into language of concepts. That's the general structure of the encoder-decoder architecture. So encoder encodes input text, which is passed to decoder, and which subsequently creates concept and values. We've got two types of encoder. One of them is BLSM, which is quite popular, and another one is CNN-based encoder. So it is based on gated unit, which we bought from the paper below. The structure is on the slide. So there are several layers of gated units which produce intermediate representation of tokens, and different sets of such gated units are used to create CNDH vectors for decoder. And another interesting thing is the heart of the decoder. It's LSTM cell with attention mechanism, and attention mechanism can provide attention vector and alignment. So now, how can we compute the similarity from each concept to the generated smart context? A simple idea is here. So we can compute either the maximum or the average similarity from concept to context. But we can do a bit more interesting thing. We can use attention. For example, here it is quite obvious that when we are disambiguating the mentioned here, we should look at the first embedding more than on all other embeddings. And we can incorporate this weight into the formula as it is done here. We have somehow to evaluate our approach, and we created a data set for the Russian language, as there was no such thing. Statistics and the link are on the slide. Okay, and now the results. So here is the baseline, and which is quite strong, and the upper bound. Globe system shows the following results, and we noted that removing linker slightly improves the situation. The results for Globe with CNN-based encoder are here, and the best results were shown with BLSM-based encoder. Though the difference is quite small, we have to perform statistical significance test, and the results are significant with the value less than 2,000. Finally, I'd like to thank my co-author Irina Nikishina, who did a great job during the whole project, and I'd like to say thank you for my colleagues from ISPRAS, from the Textero team, for valuable comments and discussion. And thank you for your attention. I'll try to answer questions.
So please, questions?
Can you show please GitHub link?
Okay.
Thank you.
It's in the paper, which is free downloadable. Yes.
Okay, more questions?
Did you try to compare your work on integration with services like Medallion from European Union and Feature Text from Virginia in the United States?
No, we didn't, and actually I'm not sure that they are working in Russian language.
I'm not sure, no, Finnish computing does not do it for Russian language, but Medallion is probably not good. I might be wrong here, but...
Okay.
And one more question. Okay. One more question. Is it possible to build this kind of system and deploy it in offline, on premises, and organization to build this kind of integration?
Sorry, I want to that.
Okay, sorry. Usually there are a lot of commercial available services that allow making entity extraction and integration from different texts. They usually have limitations. For example, you usually can put 100 kilobytes of text to do this kind of processing. And this stuff usually happens in the online manner where they use their knowledge graph, the Wikipedia, or automated data sets to make this kind of services work. What I'm wondering is how hard would be to build this kind of service to work offline, on premises, with periodic synchronization of data from Wikipedia and other data sets from time to time.
Well, I think that it's quite a technical job. So it is not that hard in scientific manner, but it's a bit hard in technical manner to synchronize because you have to download the request also the
That's the easiest part.
yeah. And actually, this part is okay. Some scientific really part. There are experiments and deploying using some corporation environment is quite hard, I think. But actually, we've got in the Excel team we have a product. You can look at the site excel.org and there's some information and probably there is some API which is available online, and actually we can provide some version which can be deployed in environment.
Okay, thank you very much.
Okay.
Have a great talk today.
We have time for one question. So thank you for nice talk. It's nice to see when there is some impact from the previous conference.
Yeah.
It's very nice. But my question is, how much the detention improved the accuracy of post approach?
Well, thank you. Good question, but actually I'm not sure that I can answer it because we didn't carry out experiments adding 2 features and 4 features. It was just an idea that attention is good for this task, and so we added a batch add. We created a batch add of 4 features at once.
Because in general, despite attention is obviously good, like not the silver bullet, so maybe just more classical parental networks without attention mechanism would show better performance. It's not like I'm suggesting, but maybe but not still. And so next question is about data sets. So could you tell me how did you collect?
Okay, how we collect them? Actually, I think that selecting good and featured articles is a pretty popular thing when you create something from Wikipedia. And last week decided to deploy our local Wikipedia, not to load Wikipedia servers. And then we just wrote some crawler which scanned through the list of good articles, the list of featured articles, did some cleanup, and that's all.
So, but how did you choose the documents in the data set?
okay, how we actually we just downloaded all the articles, and then we have to remove some articles if they were parsed incorrectly. So actually, deploying Wikipedia turned out to be a challenging task with lots of different models, and so on and so on and so on. And absence of some models caused some problems during the display, the rendering of the page. And when we saw that, we wrote several rules to remove such things. But we still managed to keep some documents.